6.1 Graphing Quadratic Functions. Buckingham team players will be able to identify and graph parts of a quadratic and find the maximum min values by completing problems as taught. Alright, a couple things here. I got the standard form of a quadratic, and you got to know what these things are. So this first term here, that's the quadratic term. This is the linear term, b of x, or b times x. And then this is just the constant. And it actually, we'll find out later, gives us the y-intercept. And the graph of a quadratic function or equation, that's called a parabola, which you guys are probably familiar with. And the a determines the direction. So this little a term right here in the front, that's in your quadratic term, that determines the direction. What I mean by direction is which way is it pointing. So here's how you could think about it. If the a is positive, you can imagine somebody smiling, because, you know, positive, happy, and so it goes up. If it's negative, you can imagine them frowning, and so it goes down. And that's how you can kind of remember what the a does. And the c determines the y-intercept, so where it crosses the y-axis. Alright? So that means just by looking at an equation, we can tell which direction it's going to go and where it's going to cross the y-axis. And we should be able to do that without even doing any math, really, just by looking at the equation. So let's give that a try. Okay, here's example number 1, and I'll say this, example 1 and example 2, we're going to use these equations throughout these entire notes. So by the end, we're going to have a graph of these two. So, direction, right away, you see that it's 2x squared in front, 2 is positive, and so you should say, hey, this thing's going to open up. And the y-intercept is 10, because we got a loner 10 out here. Easy. Why don't you guys try and do the next 3 here on your own, including example number 2 and practice number 2, but notice in practice number 2 everything's out of order. So go ahead and see if you could fill the rest of those in on your own, and I'll put the answers up in a second. Okay, so right away, direction here, still positive. There is no y-intercept here, there is no c term, there's no constant, so the y-intercept is 0. Here the direction is down because it's negative x squared and the y-intercept is negative 5. Here the direction is also down because it's negative 4x squared. And this 7, even though it's not at the end, it's still all by itself, so that's our y-intercept. Alright, so really easy. Just take a look at the equation and you got it. You got exactly where the what direction it goes and what the y-intercept is. Next thing is the axis of symmetry. This is the line that cuts the parabola in half. So check it out. This is what the axis of symmetry is. It goes right down the center of the parabola. And for parabolas that we're doing, it's always going to go up and down. So that means it's always x equals some number. Well, we can figure out what number that is by this little formula. X equals negative b over 2a. I would recommend you write that over and over again. Negative b over 2a. Negative b over 2a. Over and over and over again. You should have that memorized by the end of this lesson. And then the vertex, well, we have steps to find the vertex. So the vertex, that is the max or the min. So that's this guy right there. That's the vertex. In that situation, it's the minimum because it's the lowest term. So kind of weird to think about, but parabolas that open up have minimums. Parabolas that open down have maximums. Kind of, if you visualize the graph, it makes sense. To find x, use the axis of symmetry since it is in the middle of the graph. So this will give us the axis of symmetry line, and it also goes right through our vertex. So that's how we can always find the x value of our vertex. And also, you'll find out later, we call that the h value, h and k. So that'll give us the h value. Boom. Now, how do we find the k value or the y value of the vertex, the height of where that vertex is? Well, you plug it in to the original equation. So you plug whatever x you found into that original equation, and the y that it kicks out, that's your coordinate. Let me give you an example. So here I got y equals 2x squared plus 12x plus 10. I want to find the axis of symmetry. Remember, that's x equals negative b over 2a. Well, negative b in this situation would be negative 12 over 2 times 2 for my a. This is negative 12 over 4, which is negative 3. So x equals negative 3 is my equation. My equation for the axis of symmetry. Great. Now, if I want to find the y value of my vertex, I plug this in. So here's what this would look like. Y equals 2 times negative 3 squared plus 12 times negative 3 plus 10. Let's work this out. Negative 3 squared is 9 times 2 is 18. Negative 3 times 12 is negative 36 plus 10. 18 and 10 is 28. So this is like 28 minus 36, which is negative 8. So the y value is negative 8. That means my vertex is negative 3 comma negative 8. There's my vertex. So I use the formula to find the x, plug it into the original equation to find the y, and gives me my vertex. I want you guys to go ahead and try it with this one. It should be pretty easy to do. You don't have a b term, so your b term is 0. So go ahead and give it a try. I'll put the answer up in just a second. Okay. Your b term is 0 over 2 times 5. Well, that's just 0 over 10, which is just 0. So that's your axis of symmetry. Plug that into your original equation, y equals 5 times 0 squared. 0 squared is 0, times 5 is still 0, so you get y equals 0. So your vertex here is at 0, 0. It's at the origin. And in fact, anytime you have an equation without a b and a c term, your origin is going to be at the 0. Okay, let's go on to the next one. Okay, let's try it again here. Negative b, negative 4 over 2 times negative 1. So that's like negative 4 over negative 2, which is just like x equals 2. Plug that into your equation to find the vertex. You end up with y equals negative, just the 2 is squared, plus 4 times 2, minus 5. That's negative 4 plus 8 minus 5. And that's y equals negative 1. Therefore, your vertex is at 2, negative 1. I'm going to let you guys try practice number 4 on your own, and I'll put the answers up in just a second. Okay, let's work this out together just because you might think you did something wrong here. Then the b is 2, so you get negative 2 over 2 times the a, which is negative 4. So this is negative 2 over negative 8, which is the same thing as positive 1/4. Okay, so that is your axis of symmetry. So to find the vertex, you're going to plug that into y equals 7 plus 2 times 1/4 minus 4 times 1/4 squared. Okay, let's do a little basic arithmetic here. We get 7, 2 times 1/4. That's the same thing as 1/2 or 2/4. I'm going to leave it in fourths. You'll see why in a second. 1/4 squared is the same thing as 1/16. And negative 4 times 1/16 is the same thing as negative 4/16, which is the same thing as negative 1/4. So now I have 7 plus 2/4 minus 1/4, which is 7 and 1/4. All right. That means we got our vertex. It's 1/4, comma 7 and 1/4. Okay, all of this we're putting together so that we can graph it now. That's the whole point of this. We're going to do all 4 of those things every time we graph. And they're all pretty easy things to do, so it's not really that difficult. So for this one, let's put all the things together that we found out. We know that it opens up. We know that the y-intercept is 10. Sorry, my handwriting's a little horrible there. We know that the axis of symmetry is x equals, remember it was negative b 12, negative 12 over 2 times 2, which is 4, so negative 12 divided by 4 is negative 3. And we had a vertex at negative 3, negative 8. Alright, let's put all that together in a graph. The only thing is, my graph doesn't go to negative 8, so I'm going to make it go to negative 8. So I'm going to say negative 2, negative 4, negative 6, negative 8, negative 10. 2, 4, 6, 8, 10. I'm going to keep my x's at increments of 1 just because we can. And now I'm ready to put all this in. Negative 3, negative 8. Well, that's this point right there. That's my vertex. So that's going to be the minimum of my function. And I have this line, x equals negative 3. That's my axis of symmetry. And I have a y-intercept at 10. And what the axis of symmetry does is it gives me an automatic reflection across. So any point that I have on this side, it's going to be exactly the same on this side. Because that's what the axis of symmetry does for us. It makes it symmetrical. So if this is 3 away, then this is 3 away. So we have a point at negative 6, 10 as well. And now technically we have enough to kind of just get a pretty rough sketch of this parabola. There we go. There's a graph of y equals 2x squared plus 12x plus 10. Yeah. I'm going to let you guys try practice number 5 on your own, but I am going to remind you of all the things that we found out about it. We know that it opens down. We know that the y-intercept is negative 5. We know that the axis of symmetry is x equals 2, and we know that the vertex is at 2, negative 1. Okay, if you don't remember, it was this equation up here in the top left corner. So, I want you to go ahead and try and put all that together in a graph. And I'll check back with you in just a second. Okay, I'm going to put the graph up now. Okay, here's what it should look like. There's your vertex at 2, negative 1. There's your axis of symmetry at x equals 2. There's your y-intercept at negative 5. There's the freebie point reflected across the axis of symmetry. And I'm going to show you something else that we know. Anytime we get an equation like this, where it's just a negative x squared or a positive x squared, it's actually super easy to graph. Here's the trick. Start at the vertex. And since this follows the pattern of x squared, think about it. This was, if I was to plug in a 1, I'd get 1 squared. Well, in this situation, it's a negative 1, right? So 1 squared with a negative inside gives me negative 1. So that means I'm going to go over 1, down 1. If I was to plug in a 2, so over 2, I would get negative 4, down 4. Over 3, 3 squared is 9, down 9. It's going to follow that pattern. Anytime you have just x squared or negative x squared, all the negative does is make the same pattern go down. That's all it does. So these are really easy to graph. Once you find the vertex and it has that standard pattern, boom, it's simple. Alright, that's it for graphing parabolas. I'll see you on the next video, 6-2.